Our lesson today comes from the first section of the textbook, The Language of Algebra. Check out our learning goals. Evaluate expressions, formulas, including correct answers, correct units in the answers. Use addition, subtraction, multiplication, and division to write expressions which model real-world situations. You probably realize that doesn't sound too complicated, and some of it may seem like you've had before. In actuality, you have. Let's look at our first slide. We're more concerned about vocabulary right now and getting a good, firm basis of how the terminology of things are going to work. So if we look here, we have a variable, formula, an algebraic sentence, an algebraic expression, and an equation, all which are crucial and all are different. So if we pick one out, let's start with, I'd say a variable. Single thing. Think about what your variable definition is and see if it matches this. A symbol that can be replaced by any one of a set of numbers or other objects. We like to say a variable is a letter that stands for a number, but again, it can stand for more than one number at a time. It can be other types of objects. So as you work forward, a variable is a symbol. That X or Y is a big piece of our algebra overall, but it is nothing more than a symbol. From there, if we talk about probably the next piece, once we have a variable written down, let's say our variable is X, which is very common, and if we put something else with it, let's multiply that X times 3 and then maybe add 5 to it. Now we're not talking about a variable anymore. So we need a new definition there, and that definition would fall under the category of an algebraic expression, which is a combining of numbers, variables, and operators in a way that stands for a number. So we have combined using multiplication in the beginning. The 3x part is multiplication, plus the 5, that's using the operator of addition. So that expression, notice, does not contain an equal sign. We are not looking for an answer. It just represents a number, a bigger number than we're used to seeing. So if we have that algebraic expression and we need to put a formal thought to it, maybe we would turn it into next an algebraic sentence. A sentence, which we know in English is a completed thought, in which expressions are related by equality or inequality. So, difference. An algebraic expression could be a partial piece of something, where an algebraic sentence clearly states it is a complete thought, because of the word sentence, and it will be connected with an equality sign, equal to, or an inequality sign. That could range from less than, greater than, less than or equal to, greater than or equal to signs, could all be used. So if we go back to that sentence that we were using a second ago, 3x plus 5, if we just did something really simple and said equals 7, we now have an algebraic sentence, whereas before, without the equals 7 part, we only had an algebraic expression. So the completing piece of it makes it a sentence. It's still algebraic because it has that variable component, at least a single variable, in its work. All right, moving on. We have a formula. Well, a lot of people think, let's go to our equation next. A lot of people think an equation is the same as an algebraic sentence. Let's see what the difference actually is. Our definition here for an equation is a sentence stating that two expressions are equal. So again, you see the complete thought idea, the word sentence there, and if we put the one up we just had, 3x plus 5, equals 7. Yes, we could call that an equation because of the equal sign. So an algebraic sentence, an algebraic equation, both of those would work for this situation. But the minute you would change that equal sign to something other than equal to, you now have a less than sign in its place. We no longer have an equation. We're back to having an algebraic sentence. It is a complete thought, but it does not have an equal sign in. And our definition here says it must contain an equals to be an equation. All right, that leaves our last one, a formula. A lot of people can think of formulas that they've learned in geometry. There were quite a few area formulas, perimeter formulas that you were presented with. Now look at the formula. Formula is a sentence, so there's that complete thought again, stating that a single variable is equal to an expression with one or more different variables. So now they're being a little more specific about what that sentence, sentence must look like. So let's go to a couple of them that you learned before. You know that area of a triangle is equal to 1/2 base times height. Or some of you might say base times height divided by 2. If area equals 1/2 base times height, let's see how it fits this definition, because that is definitely a formula we learned. It is a sentence, complete thought, stating that a single variable, so we have that single variable in the letter A, is equal to, here's the equal to part, an expression with one or more different variables. So one variable is equal to everything else. So one variable set equal to everything else in your statement is a formula. And again, the key piece on a formula, it says a single variable is equal to. So could we call this an equation? We can. Can we call it an algebraic sentence? We can. So be very careful when they ask you to identify which or which. It has to be a complete thought. It has to calculate something. I've had before students say, well, isn't a squared plus b squared equals c squared a formula? Close, but not exactly. It is a formula. You like to call it the Pythagorean theorem. Help you find edges in a triangle. But if you go through it, it is a sentence, it's a complete thought, stating that a single variable is equal, stating that a single variable, we got the equal to part, but what about the single variable part? The closest to a single variable we have right there is c. C is by itself, it's a single variable, but it's squared. So to undo that squaring, you'd have to do the square root. So until we wrote this as c equals, it is not a single variable. So that would not be an example of a formula. All right, so looking back, you should be able to give a good definition on the similarities and the differences of these words. And if you have some questions or examples that you're not quite sure how many categories they would fit into, those are the kind of questions you want to bring with you to class. All right, moving on. After we understand the different vocabulary words that help us in algebra, we like to also remember that we have an order of operations. So we probably learned around 5th and 6th grade when we knew how to add, subtract, multiply, and divide. And we were starting to make them a little more difficult by throwing in parentheses and combinations of things. So if you look at these 3 questions here, it is a little practice in determining, do you know your order of operations? Now, you can obviously punch these into your calculator all day. I don't want you to do that. I want you to say, look at them. There's more than one thing going on. If I use the rule I know as order of operations, what do I get for the correct answer? Now, I'm not going to give you those correct answers right now. We can talk about them when we reconvene in class. However, one thing I do want you to think about is, were you ever given a rule for the order of operations? Order of operations in itself says there is an order to do a problem. And if you do not have an answer, which all of these do not, there is an order that you should attack the problem in. And yes, it is a, for sure, get the answer correct as long as you do the math correctly, process. Now, some of you learned, as a hint, some shortcuts maybe along the way in some of the other classes. Some people like to say this is that rule where you say, pretty please, my dear Aunt Sally. Some of you like or prefer, please excuse, my dear Aunt Sally. If you haven't heard of either of those, maybe you've heard of PPMDAS, where we talk about order. So think back to your elementary, middle school, junior high days, and see what you remember. Go ahead and jot these down and come with an answer, and we'll see how many of them we have correct and see if we have any issues or questions related to order of operations. That's all for today. Good vocabulary plus order of operations, you will be set. Bring any questions with you along with these answers to class.